Effective, proven, trusted. The Eurofighter Typhoon is the world's most advanced swing-roll combat aircraft. This is how the Typhoon is described by its creators. But is it really true? Born from a time of intense geopolitical tension and technological ambition, this aircraft is more than just a machine. It's a symbol of European collaboration, engineering excellence, and adaptability in the face of changing warfare demands. Since its inception, the Typhoon has continuously adapted and evolved, proving itself as a versatile and formidable force in the skies. But what is it about this aircraft that has kept it at the forefront of air superiority for decades? Let's find out. First, we start with its beginnings. The origins of the Eurofighter Typhoon trace back to the late 1970s, a period marked by the Cold War, when European nations sought to replace their aging fighter fleets with a next-generation aircraft capable of meeting future challenges. British Aerospace, now BAE Systems, took the lead by initiating the Agile Combat Aircraft (ACA) program, followed by the Experimental Aircraft Program (EAP) in 1982. The EAP served as a critical technology demonstrator, laying the foundation for what would become the Typhoon. Building on the EAP's success, the European Fighter Aircraft (EFA) program was launched in 1983, with the UK, Germany, Italy, and France initially participating. The goal was to develop a multi-role fighter that could provide air superiority across various combat scenarios. While the idea of a European collaborative project was promising, the journey was far from smooth. France decided to withdraw in 1985, seeking more control over the design and production of the aircraft, which led them to pursue their own project, the Dassault Rafale. The remaining partners, the UK, Germany, and Italy, continued with the project, with Spain joining them later. The challenges didn't stop. There were political disagreements, shifting defense priorities due to the end of the Cold War, and financial constraints. The reunification of Germany, for example, added financial pressure on the German government, which further complicated the project. But despite these hurdles, the EFA program pressed on. The first prototype of the aircraft, known as the Eurofighter, made its maiden flight in March 1994, and by December 1997, the four partner nations officially signed the contract to begin full-scale production, marking the culmination of nearly 2 decades of collaborative development. Just a quick moment before we unveil the rest. If you're new here, consider subscribing to this channel. Stay up to date and never miss out on the latest insights. So, what made this aircraft so revolutionary from the start? One of the most striking aspects of the Typhoon's design is its aerodynamic instability. Unlike most aircraft, which are designed to be stable in flight, the Eurofighter is intentionally designed to be aerodynamically unstable. This might sound counterintuitive, but it actually provides significant benefits, particularly when it comes to maneuverability. Being aerodynamically unstable means that the aircraft is naturally inclined to change its direction or attitude with minimal input. For a fighter jet, this is a desirable characteristic because it allows the aircraft to make sharp turns and quick maneuvers, which are crucial in air-to-air combat situations, known as dogfights. At supersonic speeds, this instability becomes even more advantageous. The aircraft can rapidly shift its position to outmaneuver an opponent, giving the pilot a critical edge in combat. To manage this instability, the platform relies on an advanced fly-by-wire system. This computer-controlled system automatically adjusts the aircraft's control surfaces to keep it stable when needed, while allowing for quick, precise maneuvers. This balance between instability and control makes the Typhoon one of the most agile fighter jets in the world, capable of performing complex aerial maneuvers with ease. Another benefit of this design is reduced drag. Because the aircraft is not designed to maintain a straight level flight naturally, it encounters less air resistance, particularly at high speeds. This not only enhances its speed, but also improves fuel efficiency, allowing the Typhoon to sustain high-speed flight for longer periods without the need for afterburners. The Eurofighter has a length of 15.96 meters, a wingspan of 10.95 meters, and a height of 5.28 meters. These dimensions contribute to its compact and highly maneuverable design, making it effective in both close-quarters combat and broader operational roles. At the heart of the fighter jet's performance are its two EJ200 engines, each capable of producing 13,500 pounds of thrust without afterburners and up to 20,000 pounds of thrust with afterburners engaged. What makes these engines particularly impressive is their ability to sustain supersonic flight without afterburners, a capability known as supercruise. Supercruise allows the Typhoon to fly faster than the speed of sound for extended periods without the excessive fuel consumption that comes with using afterburners. While the aircraft can reach a maximum speed of Mach 2, its supercruise speed is generally cited around Mach 1.5, though in some configurations, the Royal Air Force has noted a supercruise speed of Mach 1.1. This capability is a significant advantage in both combat and long-range missions, allowing the aircraft to cover greater distances quickly while remaining less detectable due to a lower heat signature. The engines are also designed with modularity in mind. They are built from 15 interchangeable modules, making them easier to maintain and repair compared to other fighter jet engines. This modularity reduces downtime and ensures that the aircraft can be kept in operational condition with minimal delays. Additionally, they feature integrated health monitoring systems, which continuously check the engine's performance and predict potential issues before they become critical. This proactive approach to maintenance further enhances the Typhoon's reliability and readiness for missions. The Eurofighter's ability to climb to altitudes of over 19,800 meters further showcases its powerful engine performance, making it a formidable opponent at any altitude. Speaking about stealth, the Typhoon is not a stealth aircraft in the same sense as the F-22 Raptor or F-35 Lightning II, but it does incorporate several features aimed at reducing its visibility to enemy radar systems. The aircraft's design philosophy emphasizes agility and performance over full stealth capabilities, but it still includes measures to minimize its radar cross-section. One of the key elements in this regard is the use of composite materials. The platform's airframe is constructed using advanced composites that are not only lightweight, but also help to absorb and deflect radar waves. This reduces its radar signature, making it harder for enemy radar systems to detect and track. In addition to composite materials, the Eurofighter employs radar-absorbing coatings on certain parts of its structure. These coatings are applied to areas like the wing leading edges, intake edges, and other reflective surfaces. The purpose of these coatings is to absorb radar energy and reduce the amount that is reflected back to enemy radar stations, further decreasing the aircraft's detectability. Although these stealth features are more limited compared to those found in dedicated stealth aircraft, they provide the Typhoon with a valuable level of low observability. When it comes to weapons and armament, the Eurofighter is well equipped. Designed to dominate both air-to-air and air-to-ground combat scenarios, the jet is armed with advanced missile systems, bombs, and a powerful internal cannon. For air-to-air engagements, the aircraft can carry missiles such as the MBDA Meteor, a beyond-visual-range air-to-air missile renowned for its extended range and high speed, thanks to its ramjet engine. This missile gives the Typhoon the ability to engage targets at distances over 100 kilometers, ensuring air superiority in complex battle spaces. The AM-120, AMRAAM, and IRIS-T further complement its air-to-air capabilities, providing the flexibility to engage both long-range and close-range targets with precision. In ground attack roles, the Eurofighter can deploy the Brimstone missile, which is highly effective against armored targets. The Storm Shadow cruise missile extends the aircraft's strike capability, allowing it to engage heavily fortified targets from a safe distance, well outside the range of enemy air defenses. Additionally, the jet can be armed with Pavway 4 and GBU-24 laser-guided bombs, offering precision strike capability against a wide variety of ground targets. The aircraft's internal Mauser BK-27 cannon, a 27mm autocannon, adds to its versatility. Capable of firing at a rate of 1,700 rounds per minute, this cannon is effective in both dogfights and strafing runs against ground targets, providing a reliable close-quarters weapon when missiles or bombs are not ideal. The Typhoon's design also allows for a flexible loadout configuration, meaning it can carry a mix of up to 12 different types of weapons on its 9 pylons and 4 semi-recessed bays. This adaptability ensures that the fighter remains a potent force in a wide range of mission types, from air dominance to ground support, making it a true multi-role combat aircraft. The Eurofighter Typhoon has undergone significant evolution since its initial introduction, with each variant, or tranche, representing a major step forward in its capabilities. These developments reflect the changing needs and priorities of the partner nations, the UK, Germany, Italy, and Spain, as well as the ongoing advancements in military technology. Tranche 1, the first production variant, was primarily designed to establish air superiority. Introduced in the early 2000s, it focused on excelling in air-to-air combat. These Typhoons were equipped with advanced air-to-air missiles, like the AEM-120 AMRAAM and IRIS-T. However, at this stage, the aircraft's capabilities were largely confined to air-to-air roles, reflecting the immediate defense needs of the time. As military requirements evolved, the need for a more versatile aircraft became clear, leading to the development of Tranche 2. This variant expanded the jet's role beyond air superiority, transforming it into a true multi-role fighter. Significant upgrades were introduced, including enhanced avionics and the ability to carry advanced air-to-ground weapons such as the Storm Shadow and Taurus missiles. These long-range precision strike capabilities allowed the Typhoon to effectively engage ground targets from a distance, marking its evolution from a specialized air superiority fighter to a versatile platform capable of handling a wide range of missions. Tranche 3 represents the most advanced variant of the Eurofighter to date. It incorporates structural enhancements to support future upgrades and is equipped with improved computing power and electronic systems. These upgrades allow the integration of even more sophisticated weapons and systems. While Tranche 3 was designed to support the integration of the Captor-E ASA radar, the radar itself was not initially installed on all these new aircraft. This radar, which offers a 200-degree field of view and can track multiple targets simultaneously with greater accuracy and speed, is a major upgrade that significantly enhances the Typhoon's capabilities in both air-to-air and air-to-ground engagements. The actual integration of the radar is part of the ongoing Long-Term Evolution (LTE) program, which ensures that Tranche 3 aircraft, and potentially earlier variants, are equipped with the latest technologies as they become available. But the evolution of the Eurofighter does not stop here. The development of Tranche 4 is already underway, and this variant is expected to incorporate even more advanced systems and technologies. These new fighters will likely feature improvements in electronic warfare, stealth, and communication systems, making them more resilient in contested environments and better integrated with other platforms in a networked battle space. These upgrades will ensure that the Typhoon remains a critical asset for European air forces and continues to play a vital role in NATO's defense strategy. In addition to hardware upgrades, there are ongoing efforts to enhance the software and avionics of the Typhoon through regular updates. These updates aim to improve the aircraft's mission planning, data fusion, and overall situational awareness, ensuring that pilots have the best possible tools at their disposal during complex missions. The evolution of the Typhoon extends beyond its airframe and weapon systems to include significant advancements in the cockpit and pilot interface. At the heart of the Eurofighter's pilot interface is the Striker 2 helmet. This helmet features digital mirror device (DMD) projectors. Unlike older helmets that relied on cathode ray tube technology, the Striker 2's DMD projectors are digital, providing a clearer, more reliable image directly onto the pilot's visor, which reduces bulk and complexity compared to older systems. The helmet is constructed from lightweight carbon fiber, making it more comfortable during high-G maneuvers by minimizing strain on the pilot. A key innovation of the Striker 2 is its integrated night vision. Unlike traditional night vision goggles, which can be cumbersome, the Striker 2's night vision is built directly into the helmet. This allows pilots to seamlessly switch between day and night operations without changing equipment, maintaining full situational awareness in low-light conditions. The helmet's customizable interface lets pilots declutter the display, focusing on the most relevant information, which reduces cognitive load during complex missions. In parallel with helmet advancements, the Typhoon's cockpit is being upgraded with a large area display, or LAD, developed by BAE Systems. This new display consolidates multiple smaller screens into a single, expansive touchscreen, simplifying the pilot's interaction with the aircraft systems. By providing a comprehensive view of flight data, targeting information, and mission parameters on one screen, the LAD enhances situational awareness and operational efficiency. Its design is highly customizable, allowing pilots to tailor the display to their specific needs, whether for air-to-air combat or ground attack missions. This adaptability Combined with the helmet's advanced features ensures that the Typhoon remains one of the most advanced and user-friendly aircraft in the world. Like every fighter jet, the true measure of its capabilities is revealed in the heat of battle. So, how did the Eurofighter prove its mettle when it first faced the crucible of combat? The platform has since established itself as a highly capable and versatile combat aircraft, with a proven track record in various operational theaters. One of the most notable deployments was during the 2011 military intervention in Libya under Operation Unified Protector. The Typhoon played a key role in enforcing the no-fly zone imposed by NATO and conducting precision airstrikes against ground targets. In Iraq and Syria, the jet has been a crucial component of the international coalition's efforts against ISIS. Deployed under Operation Shader in Iraq and Operation Inherent Resolve in Syria, the Typhoon has conducted numerous sorties, providing both air superiority and ground attack support. Beyond its combat deployments, the aircraft plays a vital role in NATO and European defense, particularly in air policing and rapid reaction missions. The Typhoon is a key asset in NATO's Baltic air policing mission, which involves patrolling the airspace over Estonia, Latvia, and Lithuania to deter and respond to potential airspace violations by hostile forces. In addition to the Baltic states, the Eurofighter is regularly deployed to other regions of Europe as part of NATO's enhanced air policing efforts, particularly in Eastern Europe, where tensions with Russia have heightened the need for robust air defense capabilities. The fighter is also central to the defense strategies of its partner nations. In the UK, the Typhoon serves as the backbone of the Quick Reaction Alert Force, which is on standby 24/7 to respond to any airborne threats. Similar roles are played in Germany, Italy, and Spain, where the aircraft is tasked with safeguarding national airspace and participating in joint NATO operations. So, as we have just seen, the Eurofighter plays a critical role both in NATO and European defense, but it has experienced mixed success in the international market. While it has achieved notable commercial victories, particularly in the Middle East, its adoption outside the consortium countries in Europe has been more limited. In the Middle East, countries like Saudi Arabia, Oman, Kuwait, and Qatar have purchased the aircraft. These deals have helped sustain the production lines and ensured the continued relevance of the Typhoon in global air forces. Saudi Arabia, in particular, has been a major customer, ordering 72 aircraft as part of a multi-billion-dollar deal that included comprehensive training and support packages. Similarly, Kuwait ordered 28 Typhoons, further solidifying the aircraft's presence in the region. However, the jet's market penetration in Europe has been more modest, especially outside the original consortium countries. While Austria did purchase a small number of Typhoons, no other European nation has adopted the aircraft on a significant scale. This limited European adoption contrasts sharply with the widespread uptake of the F-35 Lightning II, which has been chosen by several European countries, including Norway, Denmark, the Netherlands, and Belgium. The F-35's advanced stealth capabilities, integrated systems, and strong backing by the United States have made it a more attractive option for many nations seeking to modernize their air forces. One of the challenges the Typhoon has faced in the international market is its relatively high cost compared to other aircraft, including the F-35. While the Typhoon excels in many areas, its price tag and the cost of maintaining such a sophisticated aircraft have been barriers for some potential buyers. Additionally, the rapid pace of technological advancements in military aviation has meant that some nations prefer to invest in newer platforms, like the F-35, which offer next-generation capabilities. Geopolitical considerations have also played a significant role in shaping the Eurofighter Typhoon's international sales. One of the most influential factors has been the United States' approach to selling the F-35 to certain countries. The U.S. has been selective about which nations can acquire the jet, particularly in the Middle East. For instance, Israel was one of the first countries in the region to receive the F-35, reflecting its close strategic relationship with the U.S. However, other Middle Eastern nations, such as Saudi Arabia and the UAE, have not been offered the aircraft, likely due to concerns about maintaining Israel's qualitative military edge in the region. This reluctance to sell the F-35 to certain Middle Eastern countries has opened the door for the Typhoon, which offers a highly capable alternative without the political complexities associated with the Lightning II. Turkey is another example of how geopolitical factors have influenced the Eurofighter's market potential. After Turkey was excluded from the F-35 program, Due to its acquisition of the Russian S-400 missile defense system, the country began exploring alternative options to modernize its air force. Turkey is currently in negotiations to purchase 40 Typhoons as it seeks to fill the gap left by the F-35. This potential deal, however, faces opposition from Germany, one of the Eurofighter consortium partners, due to political tensions. Despite this, Turkey remains hopeful that diplomatic efforts with the UK and Spain will enable the sale to proceed. Now, the Eurofighter Typhoon has been a cornerstone of European air defense for decades, but everything has an end. As the landscape of aerial combat continues to evolve, so too must the aircraft that serve on the front lines. With the development of new technologies and the increasing complexity of modern warfare, the need for a next-generation fighter has become apparent. This has led to the initiation of the Global Combat Air Program, or GCAP, a multinational effort aimed at developing a sixth-generation fighter to complement and eventually succeed the Typhoon. The program is an ambitious project spearheaded by the UK, Italy, and Japan, with the goal of developing a cutting-edge sixth-generation fighter aircraft. This new fighter, often referred to as the Tempest in the UK, is envisioned to enter service in the 2030s and will incorporate the latest advancements in stealth, sensors, artificial intelligence, and autonomous systems. The Typhoon, while still highly capable, was designed in the late 20th century, and its design reflects the priorities of that era, namely air superiority and multi-role capabilities. The GCAP aims to push beyond these capabilities, focusing on enhanced stealth, greater integration with unmanned systems, and the ability to operate in highly contested environments. The Tempest, as the centerpiece of the GCAP, will be designed to excel in these areas, ensuring that it remains effective in the face of evolving threats. However, despite the focus on the future, the Eurofighter is far from obsolete. The aircraft is expected to remain in service well into the 2040s, with ongoing upgrades ensuring its operational relevance. These upgrades are part of a broader effort to extend the Typhoon's service life and maintain its competitive edge alongside emerging technologies. As we have seen earlier, one of the most significant upgrades is the integration of the Captor-E AESA radar. Additionally, the development of new weapon systems such as the MBDA Meteor Beyond Visual Range missile ensures that the Typhoon remains a formidable platform for air superiority. The Eurofighter consortium is also investing in software and avionics upgrades to improve the aircraft's situational awareness, data fusion, and electronic warfare capabilities. These upgrades are critical as the Typhoon will likely operate alongside the next-generation Tempest fighter, acting as a force multiplier and providing complementary capabilities in a mixed fleet. The integration of advanced data links and communication systems will enable seamless interoperability between the Typhoon and future platforms, ensuring that it continues to play a vital role in coalition operations.